Hello students, in the previous video we learned the difference between congruent figures and similar figures. Now let us know about similarity of triangles. Let us learn similarities of triangles. Congruent figures, nothing but two figures or two objects which has same size and shape. Those figures are said to be as congruent figures. In similar figures, those two figures should have same shape but not necessarily the same size. So here, similarities of triangle. You can recall that triangle is also a polygon. Triangle is also a polygon. It is three-sided figure. Triangle is three-sided figure. So we can state that the same conditions for similarities of two triangles. You can state same conditions for similarity of two triangles. That is, first one, corresponding angles should be equal. Corresponding angles should be equal. Corresponding angles, remember, corresponding angles are equal. The second one is their corresponding sides are in same ratio or proportion. Same ratio or same proportion. Then we can say that if two conditions are satisfied, then we can say that two triangles are similar. So observe here, if two corresponding angles of two triangles are equal, if two corresponding angles of two triangles are equal. If two corresponding angles of two triangles are equal, then they are known as equiangular triangle. Then they are known as equiangular triangle. So, if two corresponding angles of two triangles are equal, then they are known as equiangular triangle. So, based on this, one of the famous Greek mathematician Thales gave an important truth relating to equiangular triangle. So based on this, a famous Greek mathematician Thales gives an important truth relating to this equiangular triangle, which is as follows. So the statement which he gave is the ratio of any two corresponding angles, any two corresponding sides in, don't get confused, it is equiangular, not equilateral. Any two corresponding sides in two equiangular triangles is always the same. Is always the same. See, any two corresponding angles of two triangles are equal, then they are known as equiangular triangle. Based on this, a famous Greek scientist gave an important truth relating to this equiangular triangle is as follows. He said that the ratio of two corresponding sides in two equiangular triangle is always the same. So it is believed that he has used a result called it is believed that to give this statement he used a result called BPT theorem. BPT theorem is nothing but basic proportionality theorem. So, before going to learn this basic proportionality theorem, to understand this basic proportionality theorem, let us do one small activity which they gave in your textbook. Activity 2, page number 31. Activity 2, page number 31. We have given that draw any angle XAY. Draw any angle XAY. So I write an angle. Mark this as A. This is X. This is Y. And then set that on it is one arm is AX and another arm is AY. On one arm AX, write 5 points. Mark 5 points of equal distances. First point, second point, third point, fourth point, 5 point. And I'll mark this point as P and this as Q, this as D, this as R and this as B. So, draw any angle XAY. This is one arm and this is one arm. So, on the arm AX, mark 5 points of equal distances and naming one variable. So, if you observe here, see, the distance between all these points are equal. So, such that AP is equal to PQ. Again, PQ distance is equal to QD. Again, QD distance is equal to DR. Again, DR is equal to RB. This distance, these are all equal distance. Now, through B, draw any line intersecting R, XY. We need to, through B, we need to draw any one line that intersecting XY and mark this as C. Again, through the point B, draw line intersecting R, A, Y. So again, through D, draw an intersecting line R, A, Y, mark it as C and mark it as E. this line as E. So, observe here, the point which you draw through D, which you draw a line through a D, and which you draw a line through B is parallel. Both are parallel to each other. DE parallel to DC. So, if you observe from this construction, see here AD by DB. So, A to D divided by D to B. So, here consider this as 1 centimeter. So, A to D means 1 plus 1 plus 1 is 3. From D to B is 1 plus 1, 2. AD divided by DB. Then measure AE and AC. Measure AE and EC. So, see, AE means, if you write parallel lines of all the points means, again here 1, 1, 1, 3 centimeter lines. So, AE equals 3 and EC equals 1, 2. EC equals 1, 2. Therefore, AE by EC equals 3 by 2. So, you can see that in a triangle ABC, in a triangle A, B and C, DE is parallel to BC, DE parallel to BC, and here AD by BD equals 3 by 2 and AE by EC equals also 3 by 2. So, AD by BD equals AE by EC. AE by EC. Now, see here, you draw one angle and mark these 5 points and separate and draw a parallel lines through one line through B and one line through D. At the end, we got that AD by BD equals AE by EC. So, do you think this is a coincidence? No, this is not a coincidence. This is due to the following theorem known as basic proportionality theorem. Going to learn this basic proportionality theorem. So I will continue in the next video. Thank you.